Hello girls, this is your Ante Matric Test walkthrough. The idea is that if you've got a question that you've got full marks for, you can skip that over and go directly to questions that you need assistance with. There is a time that you can jump to for each question that you've seen on the accompanying document. And the idea is that this replaces us physically going through the test with you in class. Alright, so question 1 is a simple difference of two squares. So we're going to FOIL the bracket out to get cosec squared theta minus cot squared theta, which according to your squares identity on your information sheet is equal to 1. Right, marks are added, method that you knew to multiply out, a mark for that it was accurate, and a mark for your final answer 1. Right, question 1.2 is an identity. We'll choose the left-hand side because it's more complicated. And we're going to start with that negative tan x and convert that to negative sine x over cos x. Right, and then the cos x that's at the bottom, remember that is cos x over 1. So we can tip and times that to end up with 1 over cos x. Alright, the second fraction I'm going to leave as it is for now because there's not much you could do other than changing reciprocals, etc. But for now, let's leave that because we can see that there might be some kind of a squares identity forming at the bottom. Alright, let's deal with that bracket. So that becomes negative sine x over cos squared x plus sec squared x over sine x. Right, one of the rules with identities, whenever you have a fraction, you need to get that fraction into one fraction, two fractions into one fraction. So we've got an LCD here of sine x into cos squared x, which would make the numerator, the first numerator here would become negative sine squared x, and sec squared x will be multiplied by cos squared x. Okay, just for the next step, I just want to point out something about this term. You know that sec squared x times cos squared x, they are reciprocal functions of each other, so we could rewrite them as 1 over cos squared x times cos squared x, and that would just cancel and give us 1. Similarly, we could have made it sec squared x times 1 over sec squared x, and we'd also just get 1. Alright, so then in the next step here, we're left with minus sine squared x plus 1 over sine x cos squared x. And at the top now, using the squares identity, that becomes cos squared x over sine x cos squared x. Cos squareds cancel, and you're left with 1 over sine x, which is equal to cosec x. It's a reciprocal function, and therefore that's equal to the right-hand side. Right, question 2.1 is quadrant reduction in radians. So let's start with the sine pi over x. That's in quadrant 3, where sine is negative. And sine of x minus pi over 2 is equal to negative cos x. Okay, for an explanation there, just look on the right-hand side. Because it's x minus pi over 2, it's effectively a negative angle. So what you could have done is taken out a negative and made that pi over 2 minus x. Using your negative angles rules, the negative is at the front of the sign now, pi over 2 minus x. Right, so that's now the same as in degrees, the 90 minus, so it's cofunction rules. So sine of pi over 2 minus x becomes cos of x, but we've got the negative in front of it that we took out when we factorized the negative out of the inside bracket. Right, going back to the problem, tan pi over x is in quadrant 3 where tan is positive. Please, I hope you're using brackets. And cos squared 2 pi minus x is in quadrant 4 where cos is positive, but it's being squared anyway, so it remains cos squared x at the bottom. Right, so to tidy up, we can see that the two negatives will cancel, so we won't have to worry about those anymore. The cos squared x cancels with 1 over cos squared x at the bottom, so we're left with 1 over cos x for those two terms. And we can change this tan x, so we're going to leave the sine x. Tan x is sine over cos, but because it's at the bottom, it's actually cos over sine x. So we have cos x over sine x times the 1 over cos x that we got from the first step, and everything cancels. Right, marks are allocated. One for your negative cos x, one for your negative sine x, one for the denominator, and one for the method of replacing tan at the bottom with cos x over sine x, an accuracy mark for your 1 over cos x, and an accuracy mark for your final answer. Okay, sorry girls, I just want to go back to this page to show you where marks are allocated. So there's 1 mark for expressing tan as sine over cos. There's a mark for your cos squared x in the denominator here. There's a mark for your sec squared x cos squared x. There's a method mark for getting the correct LCD. There's an accuracy mark for finding out that sec squared cos squared x was 1. And then there's an accuracy mark for your cos squared x here in the numerator, and then a mark for your 1 over sine x. Alright, question 2.2 is reduction in radians using values instead of variables. So remember, the process here is that for each of the numerators, you've got to find a multiple of the denominator that is closest to the numerator. So we've got 6 at the bottom. So the multiple of 6 that's closest to 5 is 6. So that's going to become 6 pi minus pi over 6. And then tan will become 4 pi plus pi over 4. So we haven't changed any values yet, we've just split them up. Then in the denominator at least, sine, the closest denominator is 6 pi, so it'll become 6 pi minus pi over 3. Right, you don't need to show this step, but I'm just showing it to you so that we can see how we get to the next step if you didn't get it. Alright, so now we can simplify in the bracket. So cos 6 pi divided by 6 will give us pi minus pi over 6, and the tan at least will be tan 4 pi divided by 4 is pi plus pi over 4, and in the denominator becomes sine 2 pi minus pi over 3. Right, so cos pi minus pi over 6 is in quadrant 2 where cos is negative, so it'll become negative cos pi over 6. And tan pi plus pi over 4 is in quadrant 3 where tan is positive. So we have positive tan pi over 4. And in the bottom, at the denominator, sine 2 pi minus pi over 3 is in quadrant 4 where sine is negative. So we have negative sine pi over 3. Right, you can cancel your negatives now because we've got 2 negatives, so they're clearly going to cancel out. And now we replace with the special angles. Right, so cos pi over 6 is root 3 over 2. And tan pi over 4 is 1. The denominator is also sine pi over 3, which is also root 3 over 2. So clearly this equals 1, as the root 3's over 2's cancel. Right, marks are allocated for your method in reducing. Then you get an accuracy mark there, an accuracy mark there, and an accuracy mark there, and an accuracy mark for putting your special angles in, and then a final mark for the answer. Right, question 3 is a quadrant question where you draw a diagram and find the missing side. So 2 pi over 5 is an acute angle. It's less than pi over 2, so we know it's going to be a first quadrant diagram. Right, let's start with the diagram. I'm going to do it here out of the way. So we've got quadrant 1. We have our diagram there. The angle is 2 pi over 5. And remember that this k represents k over 1 if we had to represent that ratio as a fraction. So k is our x value, 1 is our r value, and then by Pythag, we work out that the y value is 1 minus k squared. I'm just going to go and get my dogs to shut up. Right, now that the dogs have been suitably dealt with, I can carry on. Alright, so for question 3.1.1, it's simple reduction. I hope that it's simple reduction for you. Just bear in mind, while I'm doing this video, it's currently Monday, so you haven't written the test yet, so I'm not speaking in reference to any answers that I've seen. But very often in questions like this, the question is misunderstood in that you think that we're working out the angle. where often it's given as a variable or whatever. We're not interested in what k is. We're not interested in the value of k. We're interested in representing the entire trig ratio, getting it to look like cos 2 pi over 5, and then replacing it with k. So for the first one, sine pi over 2 minus 2 pi over 5, that is a co-function reduction, so that ends up being cos 2 pi over 5, which is exactly the same as what we have up here, so therefore cos 2 pi over 5 is k. Okay, 3.1.2. Now here you've got to do a bit of manipulation because we don't have the ratio for tan, nor do we have a diagram for the angle 7 pi over 5. So we can see that that's an obtuse angle. So we're going to reduce it the same way as we did in the previous question, where we find a multiple of the denominator that's close to the numerator. So in this case, it would be 5 pi. All right, so 5 pi plus 2 pi over 5 would then simplify to pi plus 2 pi over 5. Right, so that's now a reduction into quadrant 3, where tan's positive. So we end up with tan 2 pi over 5. And then looking at the diagram, we know that tan is y over x. So we end up with root 1 minus k squared over k. All right, marks here are allocated. 2 marks for your cos 2 pi over 5 here, method and an accuracy mark, and an accuracy mark for your answer. The marks are a little bit more liberal for these questions in AP than they are in core. And then 3.1.2, you get a method mark for your reduction. Remember, you never ever have to show that step, but you're welcome to if you want to. Then there's an accuracy mark for the tan 2 pi over 5, and then an accuracy mark each for your numerator and denominator. Okay, question 3.2 is also a diagram type question. So if we look at the 3 over tan theta equals 4, and we rearrange that to get tan theta the subject of the equation, we get the following. Okay, tan theta equals 3 over 4. So that would be multiplying both sides by tan theta and then dividing both sides by 4. Right, so now if we look at the cast diagram, tan is positive in quadrant 1 and quadrant 3, but if we take this into account that says theta needs to be between pi and 2 pi, that means that there are those two quadrants, so clearly this is the quadrant that we need. Right, so let's draw the diagram. So theta is here, and we have tan is, the y value is 3. Okay, so if we look at this point then that's negative 3 and negative 4. And then by Pythag, we work out that the radius is 5. A nice little Pythagorean triple. All right, so let's go into the question now. 4 cos theta plus 2 sine theta. Again, these questions tell you not to use a calculator because we are not interested in the value of theta. We're interested in the value of 4 cos theta plus 2 sine theta. Right, so cos theta is x over r, so that's negative 3 over 5. And then sine theta is y over r, which is negative 4 over 5. Right, that simplifies to negative 12 over 5 plus negative 8 over 5. And that's minus 20 over 5, which then equals minus 4. Okay, marks are allocated here for you putting tan theta as the subject of the equation, a method mark for your answer, a method mark and an accuracy mark for your substitution, and then a mark for your final answer. All right, solve question 4, solve angle PQR. That effectively means we need to find the value of Q, the value of P, and the value of R. All three sides are given, but just remember when they ask you to solve a triangle, they are asking for all unknown sides and all unknown angles. All right, so you can start with any of these angles. I'm going to start with the one that Mrs. Grafley did in her memo. So that's Q squared, or angle Q at least. So if we look at the cos rule as given to you on the information sheet, this is what we would have. And we can now isolate cos q. You can either substitute now and then make cos q the substitute of the equation at the end, or you can do it at the beginning. All right, so cos q, we've both taught you how to do this, would be equal to p squared plus r squared minus q squared all over 2pr. Right, so do the substitution. Cos q, by the way, we chose the cos rule because all three sides are given and no angles are given, so the sine rule is not available to help us here. All right, so p squared, remember p is the opposite to angle p, so that's 22 squared plus r, which is the 15 squared, minus q squared, which is the 28. Okay, all over 2 times p times r. And you can put this straight into the calculator. You don't have to work that out. You can go straight into shift cos. Okay, 1,68 radians. Now, that's rounded off to 2 decimal places, but remember, we still have to find 2 other angles. So don't clear the answer off your calculator just yet. So that was for angle Q. So you can write that on. And then when you use your calculator, you're going to use the A and S button, the answer button, instead of typing in 1,68. All right, so now to find either P or R, let's go for P. Sine of P over its opposite. So remember, for the sine rule, I'm just going to take out these lines. For the sine rule, if we're looking at sine of P, that angle, then it must be over the opposite. So it's over 22 equals sine of Q, which we've got, 1,68 radians, over its opposite, which is 28. So therefore, sine of P, you can go straight to an answer here. You're going to put shift sign, and it'll be 22 sine of your answer, and that'll be over 28, and then that gives us a final angle of P equals 0,895 radians. And again, keep this answer in your calculator. So your previous answer now is your first angle Q, and your latest answer is 0,895. And in order to get the final angle R, we need to say pi minus angle Q minus angle R, minus angle P, and that's going to give us pi minus 1,68 minus 0,895, and that final answer is 0,56 radians. Right, marks are allocated here for the method of using the cos rule, for your accuracy of substitution, for your answer for Q, method of using the sine rule, a CA answer, meaning that if you got this answer wrong, then we would work it out accordingly, a method for subtracting the 2 angles from pi, and then finally your final answer, also a carry on accuracy. Right, question 5. Diagram shows triangle ABC. AB is perpendicular to BC. AB is 5 units. So if the information is not on the diagram, put that on. Okay, so that's 5 centimeters. And BC equals 3 centimeters. Angle CAB is in radians. The arc DE with center A and radius meets AC at D and AB at E. So they've said A is a center, which means that it is part of a circle. DE is an arc of that circle, even if you can't see the circle there. Right, so question 5.1, calculate the area of the region DEBC. All right, so we want this region, DEBC. Okay, so the first step then is to determine what the size of angle alpha is. So we can use regular trigonometry in that tan, I'll have yellow. Okay, tan of alpha is equal to 3 over 5. Therefore, alpha is equal to 1,03 radians. Right, next I'm going to work out the area of the whole triangle ABC. So the area of triangle ABC equals a half times the base times the height. We don't need the area rule because we've got a right angle triangle, and that gives us 15/2 centimeters squared. Don't round off any answers until we answer the final question. Right, so that's the area of the full shape. We now need the area of the sector. All right, so that's the first part. The second part, the area of ADE, sector ADE, is equal to, the formula is a half r squared theta, so a half into 2 squared times 1,03 radians. Remember, they told us that the radius is 2 centimeters here, so that simplifies to 2,06 centimeters squared. Okay, to 2 decimal places is fine. And then lastly, the area of shape DEBC equals 15/2, that's the area of the full triangle, minus the area of the sector, which was 2,06, gives us a final of 5,44 centimeters squared. Okay, so marks are allocated, a method mark for that and a method mark for finding out the angle of alpha, the value, then a method mark for your area formula and a method mark for the accuracy of your area of the whole shape, and then a method mark for using the correct area of the sector formula, and then a CA that obviously is a carry-on accuracy in case your continued accuracy in case your 15/2 is incorrect, and then lastly a mark for your final answer. Right, question 5.2, the perimeter of the same region. So let's just transfer the values that we already have. We know that this is 3 and that is 5. We also know that the radius AD and AE is 2 units, which means that this unit, this value at least, is 3 units, 3 centimeters. And we now need to work out AC so that we can subtract the 2 from AC to get this distance. Okay, and then we'll also have to get the length of the arc. Okay, so firstly, let's work out AC using Pythagoras. Right, so AC squared is equal to 5 squared plus 3 squared. So AC is equal to root 34. Right, so that's root 34. So then DC must be root 34 minus 2. Okay, put the surds on, don't work it out, don't round them off. Okay, and then now that we've got DC, we know that we've already discussed that BE must be 3 because it's 5 minus 2, so that equals 3. And then DE, we'll use sector length, so it's the radius times theta, which is 1,03, which is 2,06. Right, so therefore the perimeter is equal to root 34 minus 2 plus 3 plus 3 plus 2,06. Right, question 6, in the figure alongside, O is the center of the circle, the radius is 10 centimeters, ST and VU are equal at 2 centimeters, so I would put that on the diagram. So these two both equal 2 centimeters. Sorry, I don't know what I did there. Okay, so that's centimeters. And TOU is pi over 4 radians. Okay, so that's pi over 4. If the radius is 10, that means that OS is 8 and OV is 8. Right, so the only question is determine the perimeter of the shaded region STUV. All right, so we're working out the perimeter of this section. Right, so we're going to start with calculating the distance of SV. We can use the cos rule. Right, so SV squared is equal to 8 squared plus 8 squared minus 2 times 8 times 8 cos pi over 4. All right, so we can go straight to an answer there. You're going to put it on your calculators, put the surd sign first, type everything out, and we get 6,12 centimeters. Put that on your diagram. Right, so secondly, we need to work out arc TU. So remember, S equals R theta. So TU would be the radius, which is 10 times theta, which we know is pi over 4. And that gives us a value of 5 pi over 2 centimeters. All right, so this value here is 5 pi over 2 centimeters. Right, so for the perimeter of STUV, we're going to add 6,12, which was our SV length, plus the 2 radii, plus the arc TU, which was 5 pi over 2, and get a final answer of 17,98 centimeters. Right, so the marks here are added for a method for working out using the cos rule, as well as an accuracy for your answer. Then a method for working out the sector. You don't have to write this formula down, that's not necessary. You can go straight into substitution. Accuracy mark there. Method mark for adding all your 4 sides, your 4 lengths together, and then a CA mark for your final answer. Right, question 7. 2 concentric circles with the center O are shown. ODA and OCB are straight lines. That's just to imply that they are the radii of the circle. You can use ODA for the radius of the big circle, and OD is the radius of the small circle. OD equals DA, and OC equals BC, and they're obviously all equal to each other because OD is equal to OC because it's a radius. Right, the area is given as, the angle AOB is given as pi over 6 radians, and the area of the shaded region is equal to pi. Okay, so the first thing to do with a question like this, it's good to assign a variable to what we're looking for. So let OD equal R, and that would mean that OA equals 2R. Now, the other thing that we know is that the area of sector AOB minus the area of sector DOC must equal pi. So using that, we can substitute. So remember, the area of a sector is area is equal to a half r squared theta. Right, so the area of AOB is equal to a half into 2r all squared times pi over 6 minus a half, now with the area of the sector DOC, a half r squared pi over 6, and that must equal pi. Right, so tidy up here, we end up with 4r squared over 12 minus r squared over 12 equals 1. Okay, the pi's by now have cancelled out. So you can now get to a common denominator of 12 and have 4r squared minus r squared is 3r squared. The top equals 1. And so on, r squared then equals 4. Okay, because the 3 went into 12 4 times, and then we multiplied both sides by 4. So r then equals positive 2. Must be positive, remember, because it's a distance. And the original question was calculate the length of radius OD. So OD is the small radius, so we can leave it as r equals 2. All right. So marks are allocated as follows. All right. Firstly, a method for putting that equation together and getting it right. A method mark, an accuracy mark at least for your variables. And if you didn't use variables, you would still get that mark within your working out. It's possible to do it without using those variables. All right, and then you get a third mark for your substitution over there, your substitution over there, your substitution over there, for getting r squared on its own, a method, and then a mark for your final answer.